Good day to you children. In the last class, we learnt about sum of first n terms, of an AP, in which we learned that Sn, that is the sum of first n terms, is equal to n by 2 into 2a plus n minus 1 into d, where Sn is the sum, n is the number of terms, which is always a positive integer or a natural number. A is the first term of our AP. D is the common difference or the fixed number which we find in our arithmetic progression. Also, this is not the only formula to compute or calculate Sn. Another formula is Sn is equal to n by 2 into a plus an, where an is the last term or the term which we are concerned about. So an is the last term. Let us say it is the last term of our arithmetic progression, and all the other terms, that is Sn, n and a, have the same meaning as above. An is the last term. For example, if I told you to find the sum of first 50 terms of an arithmetic progression, say 1, 2, 3, 4. Find the sum of first 50 terms. Then the last term of that arithmetic progression is obviously 50, and that we take to be an. It is not the last term of that infinite arithmetic progression, but for our purpose we consider it to be the last term there. So an represents the last term. An can also be in some of the texts an is also written as or also denoted as L. This is easy for you to understand, right? L. L means the last term. In the fifth question, the first term of an AP is 5 and the last term is 45. The sum is 400. Find n and d. Here they have told us that the first term of our arithmetic progression is 5, that is a is equal to 5, and the last term is 45, that is an is equal to 45. The sum is 400, that means Sn is 400. Our job is to find the values of n, that is the number of terms, and d, the common difference of the arithmetic progression. So solution, first let us write down what is given. Given a is equal to 5, that is the first term of an AP, that is 5. Then the last term, I told you last term is nothing but an, which is equal to 45. So an is 45. The sum is 400, that means Sn, sum is always Sn, which is equal to 400. What are the values of n and d? We know that. So since we don't know both n and d, we cannot use the formula Sn is equal to n by 2 into 2a plus n minus 1 into d, because in that formula we need both n and d. But here they have given us the values of first and last term. So we will make use of the formula Sn is equal to n by 2 into a plus an. So by making use of this formula, we will first determine the value of n. Then we will use this value of n to find the value of d. So let's move on. Sn is equal to 400. It is given. n we don't know, so let's keep it as it is. A is 5 plus an is 45. So what will happen here? 400 is equal to n by 2 into 45 plus 5, which is 50. Opening the brackets, I'll write it as into 50. So now let us cancel them. 0, 0 cancels out. Because they are multiplied, I am going to directly cancel them. If there was another operation, say plus or minus here, I wouldn't have been able to cancel them. Since it is multiplication, when I transpose 50 to the LHS, it will be division. It will become division. So I am cancelling them directly. 0, 0 cancels out. 5 1s are 5 8s are 40. So 8 is equal to n by 2. 8 is equal to n by 2. This implies when I transpose 2, which is divided here, it will be multiplied. 8 into 2 is equal to n. So this implies n is equal to 16. So we solved half of our problem here. Now to find the value of d, let us make use of the formula which we use for determining the nth term of an arithmetic progression. Here, let us not complicate our problem by using the formula for Sn. It will be more complex for solving. Whereas this formula, that is an is equal to a plus n minus 1 into d, will be much easier to deal with. Here we know that an is 45, that is our last term. A is 5 plus, we just found out that the value of n is 16 minus 1 into d. This implies transposing it to the left side, we get 45 minus 5 is equal to 16 minus 1 is 15 into d. So 45 minus 5 is 40 is equal to 15 into d. So since they are multiplied and are on the same side, I'll just cancel them. 5 3s are 5 8s are. I get 8 is equal to 3d. So my d is equal to 8 by 3. This is my solution. Now let's write down the answer in sentences. The value of n is 16 and d is 8 by 3 for given AP, not for every arithmetic progression but for our given arithmetic progression. This is our answer. In the sixth question, it is quite similar to the fifth question. The first and last terms of the arithmetic progression are 17 and 350. If the common difference is 9, how many terms are there and what is their sum? Alright, here they have told us that the first term and the last term of our AP, is 17 and 350. And the common difference of this arithmetic progression is 9, that is d is 9. So how many terms, that is the value of n, how many n are there and what is their sum, that is Sn. So first let us write down given a is equal to 17, an is equal to 350, that is the last term, d is equal to 9. So now how many terms are there? That is n is equal to how much and what is their sum? Sn is equal to how much? So we know that from our second exercise, when an is given, a is given and d is given, we find the value of n using the formula an is equal to a plus n minus 1 n minus 1 into d, that is 350 is equal to 17 plus n. We don't know the value of n, so n minus 1 into 9. So now pause the video and try to solve for n. Pause the video right now and try to solve for n. Obtain the value of n. It should be equal to, n should be equal to 38. Also, after you find the value of n, to find the value of Sn, make use of the formula Sn is equal to n by 2 into a plus an. Alright, to find the sum Sn, make use of the formula n by 2 into a plus an, which will be equal to 38 by 2 into 17 plus 350. Once again, pause the video and solve for Sn, and Sn must be equal to, your Sn must be equal to 6,973. The value of Sn is 6,973. You have to solve for both n and Sn. Your answers, your detailed answers must be present in your fair books, otherwise you will go out of practice. So pause the video and solve for n and Sn right now. Don't leave it just like that. Moving on to 7th question. Find the sum of first 22 terms of AP in which D is equal to 7 and A22 is equal to 149. Here we are supposed to find the value of S22, that is the sum of first 22 terms, which is denoted as S22, when D is equal to 7, they have given it, and A22 is equal to 149, and n is equal to, they have told us first 22, so n is equal to 22. Now all that is missing here is the first term of our arithmetic progression. To find the first term of our arithmetic progression, let's make use of the formula an is equal to a plus n minus 1 into d, where an is A22 because we have the 22nd term. We don't know the value of a, so let's keep it as it is, plus n minus 1. We know the value of n, that is 22 minus 1 into d, which is 7. So 149 is equal to a plus 21 into 7. So now the product of 21 into 7 is 7 ones are 7, 7 twos are 14, which is 147. So 149 is equal to a plus 147. So transposing, we get 149 minus 147 is equal to a. So the value of a is 2. So the first term of our arithmetic progression is 2. Now since we know the value of the first term a and the last term an, to find the value of S22, let's make use of the formula Sn is equal to n by 2 into a plus an. You can also solve for S22, that is sum of first 22 terms, by using the other formula, that is Sn is equal to n by 2 into 2a plus n minus 1 into d. So here my n is 22. I will be making use of this formula. S22 is equal to n, which is 22 by 2, and a is 2 plus 149, that is the value of an. 2 ones are 2 11s are. S22 is equal to 11 into 151. 149 plus 2 is 151. So the product is 151 into 11. So our sum is, the sum of first 22 terms is 1661. That is our answer, required solution. The sum is, or the required sum is S22 is equal to 1661. This is our solution. In the 8th question, Find the sum of first 51 terms of an AP whose second term is 14 and the third term is 18. So we have to find the sum of first 51 terms, that is S51 is equal to what? We have to find it. And what is given to us is the second term, that is A2 is equal to 14 and A3 is equal to 18. Here we have to find the values of A and D. So to find the values of A and D, first let us write the values of A2 and A3 in the general form. That is A2 is equal to A plus D, which is equal to 14. This is my equation 1. A3 is equal to A plus 2D, which is equal to 18. This is my second equation. Now I'll subtract them. Let us just subtract them. What we'll get? The first, the signs are reversed. Plus becomes minus and minus becomes plus here. A minus A cancels out, 0. D minus 2D, we get minus D is equal to 14 minus 18, we get minus 4. Minus minus cancels and we get the value of D to be 4. That is D, the common difference, D is equal to 4. This is my equation 3. Now to find the value of A, put 3 in 1 or 2. I'll put D is equal to 4 in equation 1. That is A plus 4 is equal to 14. This implies A is equal to 14 minus 4, which is equal to 10. Therefore, A is equal to 10 is our answer. So now we got the values of the first term of the AP, that is A is equal to 10 and the common difference D is equal to 4. But our original question was to find the sum of first 51 terms of this arithmetic progression where n is equal to 51. Now to find the value of Sn, let us make use of the formula n by 2 into 2a plus n minus 1 into d, where n is nothing but 51. So S51 is equal to 51 by 2 into 2 into 10 plus 51 minus 1 into 4. So 51 by 2 into 20 plus 51 minus 1, 50 into 4. Now 51, further simplifying, 51 by 2 into brackets 20 plus 5 fours are 20, 200, bracket closed. So this is 51 by 2 into, opening the brackets, we get 220. So 2 ones are 2 11s are, so it is 110. So the value of S51 is 5610. This is our solution. So in this question we didn't have the value of A or the value of D, but using the information given to us, that is the values of second and third term, we found out the values of A and D, and then we proceeded to find the sum of first 51 terms of that given arithmetic progression. Moving on to the 10th question. I skipped the ninth question here because I'll solve it at the end of the exercise. In the 10th question, show that A1, A2, A3 and so on up to AN and so on form an AP where AN is defined as below. Also, find the sum of first 15 terms in each case. Here they have given some values of AN and we have to determine whether these values of ANs will give us the terms, that is A1, A2, A3 and so on, such that it will form an arithmetic progression. And If it forms an arithmetic progression, then we have to find the sum of its first 15 terms. To do that, this question has two sub questions, out of which one I will be solving and the other one will be left for you for practice, and you have to do it right now, pausing the video. Alright, so the first sub question, in which the an is equal to 3 plus 4n. Now first let us check whether this an is equal to 3 plus 4n will form an arithmetic progression. We did it in the solved examples, right? There was a similar kind of example. Now put n equal to 1. When n equal to 1, a1 is equal to 3 plus 4 into 1, which is nothing but 7. When n is equal to 2, a2 is equal to 3 plus 4 into 2, which is nothing but 11. When n is equal to 3, a3 is equal to, because I am putting n is equal to 3, n is equal to 1, n is equal to 1, n is equal to 2, n is equal to 2, and similarly n is equal to 3, n is equal to 3. So which is nothing but 3 plus 4 into 3. I am just replacing n by the numbers, natural numbers. Then this is nothing but 15. 4 3s are 12, 12 plus 3, 15. So, and it goes on like that up to an. So now let us check whether this a1, a2, a3 will form an arithmetic progression. How do we check if any given list of numbers is AP? We just check whether the difference between the consecutive terms will be a fixed number. So here, starting from the first two terms, a2 minus a1, a1 is nothing but the first term a. a2 minus a1 is equal to 11 minus 7, which is equal to 4. Similarly, next two terms, a3 minus a2, which is nothing but 15 minus 11, which is equal to 4. So similarly, when n is equal to 4, if you want, you can proceed another step. When n is equal to 4, a4 is equal to 3 plus 4 into 4, which is nothing but 19. So a4 minus a3, that is the last two consecutive terms, 19 minus 15, which is equal to 4. So this is a fixed number, that is 4. The difference between the consecutive terms, that is a2, a1, a3 minus a2, a4 minus a3, is a fixed number which is equal to 4. Therefore D is equal to 4. Therefore 7, 11, 15, 19 and so on forms an AP whose AN is 3 plus 4n. Now since the given AN, for the given AN, the list of numbers form an AP. What was the remaining part of the question? If it forms an AP, then find the sum of first 15 terms in each case. So first let us determine the 15th term. To find the sum, we have a, that is a1, which is equal to 7. Now we want the value of an, which is nothing but a15. So first let us determine what is the value of a15. I will take n is equal to 15. N is equal to 15, then a15 is equal to 3 plus 4 into 15. 15 4s are 60. 60 plus 3, 63. So a15 is equal to 63. Now to find the S15, that is the sum, I will make use of the formula Sn is equal to n by 2 into a plus an, where n is equal to 15. So S15 is equal to 15 by 2 into a is 7 plus 63, that is a15. So which is nothing but S15 is equal to 15 by 2 into 70. So 2 ones are 2, 35s. This implies my S15 is equal to 525. So the sum of first 15 terms for the given AN and for the formed AP is 525. Similarly, it's your job now to find whether this AN is equal to 9 minus 5n will form an arithmetic progression, and if it forms an arithmetic progression, then you have to find the sum of first 15 terms of that arithmetic progression. Pause the video and try to work it out right now. Don't keep it pending. In the 11th question, the sum of first n terms of an AP is 4n minus n square. What is the first term? What is the sum of the first two terms? What is the second term? Similarly, find the third, the 10th and the nth terms. In this question, it is a little bit different one. In this question, they have told us that Sn is equal to 4n minus n square. This is our given. They have told us that the sum of first n terms of an AP is 4n minus n square. Alright. So using this information, we have to find the first term of our AP, that is A1, and sum of the first two terms, that is A1 plus A2. Then what is the value of the second term, that is the value of A2. Similarly, value of A3, A10 and AN, using just the information that Sn is equal to 4n minus n square. Before we move on to finding the values, let us go back a little bit to understand what this sum of first n terms actually means. So we have been dealing with problems which ask us to find the sum of first n terms of an AP. So consider an arithmetic progression 1, 2, 3, 4, 5 and so on. So now if I were to tell you to find the sum of first term of an AP, only the first term, not the first two terms, just the first term of an AP, sum of first term. That is, if I ask you to find the value of S1, right, where n is equal to 1, we say that the sum of first term S1 is nothing but the first term of our AP, A1, agree? Because if I try to find the sum using the formula 1 by 2 into 2a, 2 into 1 plus 1 minus 1, that is because n is equal to 1 into 1. For the given AP, D is 1. So what we get, the remaining answer will be 1. Try to simplify it, you will get the answer to be 1. S1 is 1, which is nothing but the very first term of our AP. Similarly, if I tell you to find the sum of first two terms of our AP, so if I were to find the first two terms, then S2 is equal to how much? N is equal to 2. Then S2 is equal to 2 by 2, that is n by 2 into 2 into 1, 2a plus 2 minus 1 into 1. So 2 ones are 2 ones are, which is nothing but 2 plus 1, which is equal to 3. So S2 is equal to 3, which is also first two terms, sum of first two terms, 1 plus 2, that is A1 plus A2 is equal to S2, which is equal to 3. So now I can replace A1 by S1, because here S1 is nothing but S1 will be equal to A1. So I can write it as S1 plus A2 is equal to S2. This implies S2 minus S1 is equal to A2. Generalizing this result, we get Sn plus 1 minus Sn will always give An plus 1. Now from what we learned just now, to find the first term, because our first question is to find the first term of our AP. First, let us, when n is equal to 1, we will get S1 is equal to 4 into 1 minus 1 square. I am just putting 1 in place of n here. Alright. So, S1 is equal to 4 into 1 minus 1 square, which is nothing but 3. So, this is the value of our first term, because just now in the example we saw that sum of first term means it is only the first term. Alright. So, our A, we know that A is equal to S1, which is equal to 3. This is the value of our first term. So, now the second question is, what is the sum of first two terms? So, the second question is what? What is the sum of first two terms? We denote first two terms as what? First two terms is denoted by S2, since the value of n here will be equal to 2. When n is equal to 2, S2 is equal to 4 into 2 minus 2 square, which is nothing but 4. So, our sum of first two terms, therefore, sum of first two terms is 4. This is our answer. Next part of the question is to find the second term. To find the second term, that is our A2, we will make use of the formula Sn plus 1 minus Sn will give us An plus 1. So, by subtracting S2 minus S1, we will get the value of A2. Our question is to find the second term. We know that Sn plus 1 minus Sn is equal to An plus 1. Here, let n is equal to 1. So, we get S2, because n is equal to 1, 1 plus 1, 2, minus S1 will give us once again 1 plus 1, 2, A2. So, what is the value of S2? We found the value of S2 just now was 4 and the value of S1 was 3. So, 4 minus 3 is equal to 1, which is equal to our second term A2. Therefore, A2 is equal to 1. The question does not end here. They also want us to find the values of A3, A10 and An. So, to find A3, we have the value of S2 now. So, we must find the value of S3. So, when n is equal to 3, our S3 will be, from the given information, Sn is equal to 4n minus n square. So, S3 will be 4 into 3 minus 3 square, which is nothing but 3. So, the value of our S3 is 3. Now, S3 minus S2 will give us A3 by making use of An plus 1, Sn plus 1 minus Sn will give us An plus 1. So, S3 minus S2 will give us A3. We know that value of S3 is 3 minus value of S2 is 4. 3 minus 4 is minus 1, which is equal to the value of A3. So, the third term is A3. To find the 10th term, we have to find S10 and also to find A10. To find A10, S10, we have to look at S10 and also the value of S9. To find the values, first make use of this information given to us, that is Sn is equal to 4n minus n square. So, when n is equal to 10, 4n minus n square will be S10 is equal to 4 into 10 minus 10 square, which is nothing but minus 60. Similarly, to find S9, when n is equal to 9, S9 is equal to 4 into 9 minus 9 square, which is equal to minus 45. So now S10 minus S9 is equal to A10. S10 is minus 60 minus of minus 45 is equal to A10. This implies minus 60 minus into minus plus 45 is equal to A10. This implies minus 60 plus 45 minus 15 is equal to A10. So the 10th term of our arithmetic progression is minus 15, whereas our third term is minus 1, and the value of our second term was 1, and our first term was 3. That is S1 is equal to A1 or A, which is equal to 3. So now lastly we have to find the value of An. To find the value of An, we need values of Sn. We know Sn is equal to 4n minus n square. We have to find Sn minus 1, the value of Sn minus 1. So put n is equal to n minus 1. That's what we have been doing, right? To find the sums, we are just assigning numbers to n. We put n is equal to 1, we got S1, that is the sum of first term, which will be equal to first term. Then we put n is equal to 2, we got the sum of first two terms, which was nothing but once again the sum of first two terms, that is A1 plus A2. Then we put n is equal to 3, we got the sum of first three terms, that was S3. So we have been assigning the values, the numbers to n to find the required values. So to find n minus 1, that is sum of first n minus 1 terms, we will put n is equal to n minus 1 in the given expression of Sn. What will we get here? Sn minus 1 is equal to 4 into, replace n by n minus 1 minus n minus 1 whole square. So now let's simplify them. So using the distributive law, 4 into n, 4n minus 4 into 1, 4 minus into brackets, this is of the form a minus b whole square, which will be nothing but a square, that is n square, minus 2ab, that is 2 into n into 1, 2n, plus b square, that is 1, because 1 square is 1. So now opening the brackets and simplifying, we get 4n minus 4 minus into n square minus n square minus into minus plus 2n minus into plus minus 1, which is nothing but minus n square 4n plus 2n plus 6n minus 4n minus 5 minus 5 minus 4 minus 1, we get minus 5. So the value of Sn minus 1 is minus n square plus 6n minus 5. So now to find An, we know that An is equal to Sn minus 1. So let's put all the values together. We know that Sn is 4n minus n square. It was given in the question, minus into the brackets minus n square plus 6n minus 5. This is the value of Sn minus 1, which we just found out. So now 4n minus n square, as it is, minus into minus, we are opening the brackets, minus into minus, plus n square, minus into plus, minus 6n, minus into minus, we get plus 5. Minus n square plus n square cancels out. 4n minus 6n, we have minus 2n plus 5. So this is the value of our An. An is equal, the nth term of our given arithmetic progression is 5 minus 2n, or minus 2n plus 5. In the 12th question, we are told to find the sum of first 40 positive integers divisible by 6. So, it is nothing but writing the multiplication table for 6 and finding the sum of first 40 multiples. So, solution given the first 40 positive integers which are divisible by 6 are 6, 12, 18, 24, then 30 and so on up to 240. That is the 40th positive integer which is divisible by 6. That is nothing but 40 into 6. 6 fours are 24 plus 0, 240. So now it forms an arithmetic progression. 12 minus 6, 6, 18 minus 12, 6, 24 minus 18, 6. So it is an arithmetic progression with a is equal to 6, d is equal to 6, n is equal to 40, an is equal to 240, and you are supposed to find s40, that is the sum of first 40 positive integers which are divisible by 6. So now we know that Sn is equal to, make use of either formula where n by that is Sn is equal to n by 2 into 2a plus n minus 1 into d, or Sn is equal to n by 2 into a plus an. Since I have the first and last terms here, I will make use of the second formula where n by 2 is equal to a plus an. It depends which formula you are going to use. It depends on what information you have. Okay, here I have the first and last term, so I will make use of the formula Sn is equal to n by 2 into a plus an. If I didn't know the last term, then I would have made use of the first formula to find Sn. Both are one and the same here. You can try solving this sum using that formula. You will get the same answer. So my S40, because n is equal to 40, S40 is equal to 40 by 2 into 6 plus 240. 2 ones are 2 20s are, which is nothing but 20 into 246, which gives S40 is equal to 4920. So this is the sum of first 40 positive integers divisible by 6. This is the sum. Whenever they ask you to find the sum of these many positive integers divisible by this some number, say 11, 12, 15, 8, 9, anything, just write the multiplication table for that number up to the given terms. Suppose they ask you to find the sum of first 20 positive integers divisible by 5, then your list of numbers will be 5, 10, 15 and so on up to 25 is that is 100. So your a is 5, an is 100 and n is 20. You can find S20 there. Moving on, in the 13th question, which is quite similar to this one, find the sum of first 15 multiples of 8. It is another way of asking you to find the sum of first 15 numbers which are divisible by 8. Rather than asking that the numbers are divisible by 8, they will directly ask you to find the sum of first 15 multiples which are multiples of 8. So it is a straightforward question where your list of numbers will be 8. This is the first multiple. 8 ones are 8, 8 twos are 16, 8 threes are 24, 8 fours are 32 and so on up to 15 multiples, right? So 15 eights are 120. So this is your list of numbers with a is equal to 8, a15 is equal to 120, n is equal to 15. So what is S15? So once again I will make use of the formula Sn is equal to n by 2 into a plus an. Here the common difference is once again 8. 16 minus 8, 8. 24 minus 16, 8. So t is 8. You can make use of either formula. There is no mistake there. So 15, since my n is 15, so s 15, n by 2 will be 15 by 2 into 8 plus 120. So which is nothing but 15 by 2 into 128. So 2 ones are 2 6 are 2 4s are, which implies minus 15 will be equal to 960. This is my answer, or this is our answer. In the 14th question, we are supposed to find the sum of odd numbers lying between 0 and 50. So first, using the given information, let us write down the odd numbers which lie between 0 and 50. 0 is neither odd nor even, so the first odd number is 1, 3 because 2 is even, then 5, then 7, and so on up to 50 is an even number. So the last odd number is 49. Now let's see whether this forms an AP. 3 minus 1, 2. 5 minus 3, 2. 7 minus 5, 2. So this is obviously an AP with A is equal to 1, D is equal to 3 minus 1, which is equal to 2, and AN is equal to 49. So what is the value of n here? N is 25. How is n 25? That is a question for you. Try making use of the formula an is equal to a plus n minus 1 into d to find your value of n, which will be equal to 25. To find the sum, Sn is equal to, since I have my first term and my last term, I will make use of the formula Sn is equal to n by 2 into a plus an, which is equal to 25 by 2 into a is 1 plus 49, which is nothing but 25 by 2 into 50. 2 ones are 25. So 25 into 25, 25 square is 625. So the sum of odd numbers, therefore the required sum is 625. This is our answer.